Today we're going to begin one of my absolute favorite lessons in geometry because what we're going to learn today is one of the most applicable items that we will learn in this class, and that's going to be trigonometry. So before we get there though, we do have a couple of reminders of a couple things we've learned along the way. So just a reminder, your triangle inequality says the sum of the lengths of any two sides of a triangle must be greater than the third. So just a reminder of that theorem. Another reminder here, if c squared is less than a squared plus b squared, then the triangle is acute. So remember that c value is always your biggest number. And if c squared is greater than a squared plus b squared, the triangle is obtuse. Final reminder, we already know if c squared is equal to a squared plus b squared, that is a right triangle. So just a reminder from the previous lesson's notes from back when we talked about Pythagorean theorem, just some little review reminders. A couple other reminders here are 45, 45, 90 rules that we learned in the previous lesson. Says that the hypotenuse equals the leg times the square root of 2. And the 30, 60, 90 rule says that the hypotenuse equals the shorter leg times 2. And the longer leg equals the shorter leg times the square root of 3. So today, like I said, we're going to get into one of the most applicable things that we're going to learn in this class. So not only do 45, 45, 90s have rules that they follow, and 30, 60, 90s, but every type of right triangle in the world has its own set of rules that it follows. They're not as pretty. They often have really, really ugly fractions and decimals. So rather than trying to memorize all of those, what they've done for us is our calculator has been programmed to remember all of those rules. So today we're going to dive into what if you have another type of right triangle, one that's not a 45, 45, 90 or a 30, 60, 90. Those are the only two sets of rules, if you will, that we're going to need to make sure we know because Trig is going to take care of all the other types of triangles for us. So, before we begin, let's talk about what is a trigonometric ratio. So it's the ratio of the lengths of two sides of a right triangle. And remember guys, you can pause this video at any point to write down anything that you view as valid. So every time we set up for a trig problem, we're always going to begin by labeling where's our hypotenuse, where's our opposite, and where is our adjacent side from a particular viewing point. So for example, if I declare A as my viewing point, I'm always going to mark that. That's just for me to help me remember where is my eye, where am I looking from, where's my viewing point. So if I'm looking from A, no matter what, my hypotenuse is always going to be across from that right angle. So this is my hypotenuse. My opposite side is going to be whatever is across from my viewing point. And my adjacent is always what's right next to my viewing point, but that's not my hypotenuse. So that's why we label that first. Now, if we switch our viewing point to where we're looking from B, remember that our hypotenuse never moves, so this is still the hypotenuse, but now my opposite is over here, and my adjacent is here. Last but not least, if we try to look from C, our opposite and our hypotenuse are in the same location. So because of that, we will never set up a trig ratio or a trigonometric ratio from the 90-degree angle. We're always going to be looking from one of the two acute angles that we have either here or here. With that being said, we've got to know how to get our calculator to do what we want it to do. So what your calculator has done for you is it's memorized the set of rules for every type of right triangle in the world. But we've got to be able to get that calculator to do what we want it to do, so we've got to understand kind of what's going on behind it. So there are 3 trig ratios that we're going to talk about in this class. That's sine, cosine, and tangent. Now on your calculator, sine is abbreviated SIN. But remember that that is not sin, okay? This is not a Bible history class, this is math class, so we're going to pronounce that as sine. So the sine ratio is always formed by putting the opposite side over the hypotenuse. The cosine ratio is always formed by putting the adjacent over the hypotenuse. And the tangent ratio is formed by putting the opposite over the adjacent. Now you are going to need to memorize how we set these up. So I've got 3 options for you here. Sine, cosine, and tangent are almost always presented in that order. In fact, if you look at your calculator, you should have sine, cosine, and tangent in that order on your calculator. And you are going to need to have a calculator for this particular lesson. So you may want to take a moment and see if you can grab one of those. If not, on Canvas there should be a link to how to download a calculator onto your Chromebook. So, in terms of memorizing these, like I said, I'm going to give you 3 hints for kind of how to memorize those. Because they're always in this order, we could say orange horses always have orange ankles. And that's what my teacher taught me in high school. It was something kind of silly, something kind of strange, but it just helped me memorize the order. Orange horses always have orange ankles. Now the other option is a little phrase that's going to rewrite these a little bit different. So if I look at this, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we're going to say that as SOHCAHTOA. SOHCAHTOA. So that's your second option, as we can think of that as SOHCAHTOA. And the last option for memorization is kind of silly, kind of funny. Some old hippie caught another hippie tripping on, and I'm going to fill that in with apples. Okay, we're walking through an orchard here, maybe perhaps you can fill it in with a different word if you like. The main thing here, guys, is we just want to make sure we can memorize how to set up sine, cosine, and tangent. So again, orange horses always have orange ankles, SOHCAHTOA, or some old hippie caught another hippie tripping on apples. So let's put this into practice. If we want to find the sine, cosine, and tangent from R, remember that we're always going to mark our viewing point, and then we're going to start to label hypotenuse, opposite, and adjacent. My hypotenuse is across from T. My opposite is here, and my adjacent is right next to R. So now that we've labeled our sine from R, remember our sine ratio says opposite over hypotenuse, so 18 over 82. And it says write it as a fraction, and then write it as a decimal rounded to 4 decimal places. So in our calculator, we're going to go ahead and type 18 divided by 82. We end up with approximately 0.2195. And we're going to talk about why we did that here in just a second. Then we're going to form our cosine ratio. So remember, cosine is adjacent over hypotenuse. So we're going to set up 80 over 82 and then round to 4 decimal places, which ends up being approximately 0.9756. And tangent from R is opposite over adjacent. So 18 over 80, rounded to 4 decimal places is approximately 0.225. That only has 3, so we could actually put an exact equal here if we'd like. So with that, remember that if you struggle to set up these, we can write every time we do these questions SOHCAHTOA to help us remember how to set these up. So sine opposite over hypotenuse, that 18 over 82. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now back in the day, before we had calculators that were programmed to memorize things for us, what we had to do is we had to take these numbers, we had to take these values and find them on a chart so that we could figure out how big is this angle right here, this angle R that we looked from. So if we look at this next chart, what I would have to do is I would have to find the decimal equivalent for sine, cosine, and tangent to determine the degree. So if I look back here, my tangent was an exact 0.225. So I'm going to look at the tangent column, which I have some here and some here, and I'm going to find 0.225. And if you notice, that's in between these two numbers, which would tell me that my degree is between 12 and 13 degrees for that angle. If we had looked at cosine, 0.9756, that's right in here as well. And if we looked at sine, it's right in here as well. So all of that to tell us that we know that this degree, angle R, is somewhere between 12 and 13 degrees. But like I said, we have trained our calculators to give us this information already. So instead of carrying around this bulky chart or having to memorize things, now I'm going to show you how do you use your calculator to figure this out. So let's start first with what we know. If we're trying to find the value of x, remember that you always need to set up your viewing point. So I'm viewing from an angle that I know. So I could view from 32, or if I really wanted to, I could do 180 minus 32 minus 90, and I end up with 58 degrees. And I could make that my viewing. However, it's just easier most of the time to use what they already give you, so we're going to set up our viewing eye from 32 degrees. So labeling what we have our hypotenuse, our opposite, and our adjacent. Now if you notice, my hypotenuse is blank, which means I'm not going to use the hypotenuse at all. So when I look back to SOHCAHTOA, I need a ratio that doesn't talk about the hypotenuse at all. So I need the tangent ratio, because those are the two pieces of information that I have. I have the opposite and I have the adjacent. So I'm going to start with tangent from my viewing angle should equal my opposite over my adjacent. At this point, you have set up the problem. Now all we need to do is get x by itself, just like we do for any other question. So since 11 is divided by x, we're going to multiply to get it out of the denominator. What we do to one side, we have to do to the other. So now I have x being multiplied by something. So to get rid of that multiplication, I need to divide. So now I'm going to divide by that ugliness, tangent of 32. And what I do to one side, I can do to the other. Now, despite the fact that that's not real pretty, my calculator can do everything else for me on its own. However, we need to make sure that we are in the correct mode. So if you have what I have in the classroom, those little blue calculators, make sure that you see DEG in the bottom right-hand corner of your screen. If you don't, hit the DRG button, click Enter on Degree, and then exit out. If you have a TI-84, you should have a Mode button. Go to the Mode button, change from radian to degree, hit Enter, and then close that out. Because we're looking at degrees. Now when you get to Algebra 2, they're going to give you a new way to measure angles in terms of radians. But we haven't talked about those yet, so we need to make sure that our calculator is understanding that the numbers we're putting in are in terms of degrees. Once our calculator is set up, I can hit 11 divided by tangent of 32. Make sure you close up that parenthesis there just for good measure at the end. Hit Enter, and that tells us that x is approximately 17.6 if I round to the nearest 10. So what we've now done is we've forced our calculator to use a trig ratio, which it has memorized, to figure out that missing length. So So if we had this triangle out in the real world somewhere, we could figure out how long this particular part of the triangle was by using our calculator. So let's try another together. Again, you could solve for the other angle and use that as your viewing angle if you want, but it's easier to use the one they've already given you. Then label hypotenuse, opposite, adjacent. You'll notice here that my adjacent side is blank, so I cannot use the adjacent side. I have to use opposite and hypotenuse. So if I look back at my trig ratios, the sine ratio talks about the opposite and the hypotenuse. So I'm always going to say my sine, cosine, or tangent from my angle, or from my viewing point, should equal the sine ratio, which is opposite over hypotenuse. Then I'm going to solve for x like I normally do. X divided by something means that we need to multiply by that something. And then my calculator can handle that for me. 20 times the sine of 35. Again, make sure you close that parentheses just for good measure. And we find out that x is approximately 11.5. And you'll notice here, guys, we are rounding to the nearest tenth for these side lengths. You're going to need to do that because your calculator will give you many, many digits, but we're going to round to the nearest tenth. I would encourage you to try number 15 on your own and then come back and watch the video to make sure you did it correctly. So the last one, our viewing eye is at 41. This is my hypotenuse, my opposite, and my adjacent. My opposite doesn't have a number or a letter on it, so I can't use the opposite. So adjacent and hypotenuse, that's the cosine ratio. So the cosine from my viewing eye, or from 41, should equal the adjacent side over the hypotenuse. Since x is being divided by something, I'm going to multiply by that something. And then I'm going to have my calculator do 11 times the cosine of 41, and I find that x is approximately 8.3. So again, guys, the reason that we're using this is because we don't want to memorize all of these combinations of right triangles that we can have. We want to rely on our calculator to do the bulk of that memorization for us. Here's a couple of other examples. You'll notice here now we're bringing in multiple variables, so we're going to need to decide which variable we're going to find first and which one we're going to find second. So starting at number 10, I've got 32 as my viewing eye, my hypotenuse, my opposite, and my adjacent. And I'm going to go in alphabetical order here and solve for x first. So I'm not going to use my adjacent side just yet because I don't want two variables within my equation. So I'm going to focus on only the opposite and the hypotenuse. So looking back at my SOHCAHTOA, the two sides I have are the opposite and the hypotenuse, which tells me I need to use the sine ratio from 32 should equal my opposite over my hypotenuse. Since x is being divided by 18, we're going to multiply by 18. And then I can have my calculator do that for me. 18 times the sine of 32 tells me that x is approximately 9.5. When I solve for y, I'm going to try not to use a rounded answer. So despite the fact that I know what the opposite side is, when I solve for the y value here, I'm going to try not to use that, just in case A, I made a mistake, or so that I don't have a double rounded answer. So with that, we are not going to use the opposite side, but we do have the adjacent and the hypotenuse. So adjacent and hypotenuse is cosine. So the cosine from 32 should equal the adjacent over the hypotenuse. Multiply by that denominator, and then have our calculator do the work for us. 18 times the cosine of 32 is approximately 15.3. So now I've found both of those two variables. Go ahead and try number 11 on your own, and then come back to check. For number 11, we have our hypotenuse, our opposite, and our adjacent. I'm going to solve again in alphabetical order. You can do whatever order you prefer. So if I'm focusing on the hypotenuse and I know the adjacent, that's the cosine ratio that talks about those two sides. So the cosine from 48 should be the adjacent over, oops, and I wrote those backwards. My adjacent side is 10, so 10 over my hypotenuse. Since 10 is being divided by a, I'm going to multiply by a. I now have a times the cosine of 48 equals 10. If I'm trying to get a by itself, it's being multiplied by something. So we're going to divide by that something. And what we do to one side, we have to do to the other. So in my calculator, I'm going to type in 10 divided by the cosine of 48 to find that a is approximately 14.9. Again, I'm going to try not to use an answer that I came up with on my own. So I'm not going to use this answer. So looking at the information that I'm going to focus on now, I have opposite and adjacent, which is the tangent ratio. So tangent from 48 should equal the opposite over the adjacent. To get b by itself, I just multiply by that denominator. 10 times the tangent of 48 should equal approximately 11.1. Then I have both of my answers, and we're good to go. Now, within these pictures, there are lots of right triangles, and we've got missing information all around. So if you notice, let's focus on 28 together. We're kind of going to jump around a little bit here just for sake of time with the video. We've got one right triangle on the left and one right triangle on the right. But the one on the right has two unknowns. So I'm going to find y first, and then I'm going to find z using y. So with that, we're going to look from 30 degrees. We currently have our hypotenuse and our opposite. The sine ratio is what talks about those two things. So the sine from 30 should equal our opposite over our hypotenuse. So we're going to multiply by that denominator, and we end up here. So 150 times the sine of 30 tells me that y is 75. Now before we continue, notice that that was a 30, 60, 90 triangle, and our calculator gave us the correct answer using the 30, 60, 90 rules. So our trig functions can also be used for those triangles. However, your calculator will not leave your answer in simplest radical form. So if we were solving for this side, we would have 75 square roots of 3, which your calculator would not tell you. So you need to be careful with this, using trig to find those 30, 60, 90s, so that we make sure we leave our answer in simplest radical form if we can. Also a note here, these trig ratios only work for right triangles. So notice that's why I specified that we have a right triangle on the left and the right side of this figure. So we figured out now that y is actually 75. And we verified that with our 30, 60, 90 rules. So I'm going to focus on this triangle now. So this is now my viewing eye. That makes 75 still my opposite. And that makes z my adjacent. And again, notice I said that was a 15 because I made that look like a 1. That is a 75 there just before we start. So now looking from 40 as our viewing eye, we have opposite and adjacent, which is the tangent ratio that talks about those two sides. So tangent of 40 should equal the opposite over the adjacent. Get your variable out of the denominator by multiplying. And since, I'm sorry guys, I have a typo there. I'm going to fix that. That should be 75. Since z is being multiplied by something, we're going to divide. It's going to cancel out. And I'm going to take 75 divided by the tangent of 40 to end up with z being approximately 89.4. At this point, we've given the value for both variables, and we've got our final answer. I would recommend that you try number 29 on your own, and then come back to check. Notice that the figure on the left is a 45, 45, 90 triangle. If I recognize that, I don't even have to use a trig ratio. I know that y is also 82, because the two legs are supposed to be congruent in a 45, 45, 90. So I already know that y is 82. Then I'm going to look at this triangle on the right and solve. Now, if we didn't recognize that that was a 45, 45, 90, so the legs were the same, we could have used trig, and your calculator should give you that same answer of 82. So either way, you should get there. Looking from our viewing eye of 28 degrees, we have our adjacent and our opposite. So opposite and adjacent is tangent. So tangent from 28 tells me that I have 82 over z. Multiply by that denominator. I now have z times the tangent of 28 equals 82. Since z is being multiplied by something, we're going to divide by that something. And what we do to one side, we do to the other. And on the right, we have 82 divided by the tangent of 28. So we find out that z is approximately 154.2. The next examples here are just some word problems. So a skateboarding ramp is 12 inches high and rises at an angle of 17 degrees. How long is the base of the ramp? So looking from our viewing angle, we have opposite and adjacent. That's tangent. So the tangent from 17 should equal 12 over x. Multiply by that denominator to get x out of the bottom. Now, since x is being multiplied by something, we need to divide. So we're going to divide both sides by the tangent of 17. And our calculator can do the rest for us. So 12 divided by the tangent of 17 tells us that x is approximately 39.3. The next one has an escalator. It's got a vertical rise of feet and inches here, so we are going to have to do a little bit of conversions. So I've got 9.5 inches added on to the fact that I've got 195 feet. So if I do that conversion, I've got 2,349.5 inches. I've got an angle of 10.4, and I'm looking for how long is the escalator. So looking from our viewing eye, we have our opposite and hypotenuse, which is sine. So the sine from 10.4 should equal our opposite over our hypotenuse. Multiply by the denominator. Since x is being multiplied, we need to divide. And I left off a digit here, so I'm going to go back. Notice I left off my 9, so I'm going to make sure that's in there. And I'm going to divide. Even though this isn't real pretty to look at, our calculator can handle that for us. So my final answer is going to be x equals whatever 2,349.5 divided by the sine of 10.4 actually is, which tells me that x is approximately 13,015.2. And this is in terms of inches. So if they ask us to convert to the nearest foot, we are going to divide that by 12. So x is approximately 1,084.6 feet. Guys, this gives us how to use the trig ratios for finding side lengths. The next video will teach you how to use this to find angles. Have a great day.